if you don't know your past, you don't appreciate your current and your future. So and so I mean, there's a lot of details in these technologies we are not going to cover, but we will focus on something if you go to the field you're gonna use, right? So so we're gonna talk about the network layer, the IP layer in here, and we'll see how much we could cover today, but we'll try to go sequentially. Any questions from the first half lecture? No questions at all. Shall I ask myself? Badr? Badr is not here. All right. Too early to ask. Let's give them a few minutes. So let's move on. So the conceptual level, yeah, in the conceptual level, we could think of the global internet as a black box network that connects billions, not millions anymore, billions of people through computers. Each one of us right now have like maybe like 5, 6, 10 IP addresses, right? I mean, you'll have a PC, you'll have a laptop, you'll have an iPhone or a phone, all right? If you have IoT devices, okay, if you have an IP pad, right? If you have a watch, a smartwatch, all of them, they have IP addresses. They are nodes connected to the internet. So how are messages and how are data transmitted and how they are? This starts from the application layer. We know that they're gonna go down to the network layer. I'm sorry, transport layer, network layer, data link layer, and they're gonna go through the physical. Somehow they will reach to the other destination with no errors. So there's a lot of things are done to receive this packet, right? All right, so as you see in here, so at your application layer, let's say an email, okay, the data will be sent down to the transport layer. All right, usually it's a TCP, not UDP, TCP. It's gonna go to the network. The network could add IP address to the packet. Then it goes down the data link layer. It has to know the source and destination IP addresses, and then through the physical, and it's gonna go to the internet. This internet is a big story. It's like you said, and here is a black box, but if you open this black box, you'll see miracles happening there. A lot of things communicating and handshaking and communicating. So, and the data will be sent through this black box internet to the destination. In this case, is a laptop called B. And the data first gonna go from the physical. You strip a header. It's gonna go to the data link. You strip a header. Then you go to the network. You read the header, strip the header, it goes to transport. You read the header, strip the header, gonna go to the application. All right, so how is that happening? So internet as a combination of LANs and WANs connected together. As you see in here, this black box, take a look at it. All right, there is no one line connecting the source and the destination. It's like a switched network. A switch network. So you have a connection device, which is usually a router, and this router is connected by links. All right. So you have a host in here, and then you have a link in here connected to the network, and it's gonna go from a router. Then it has to pick a route. It's gonna go this way or this way. It's gonna go this way or it's gonna go this way. Anyways, it has to go from here to here, and there's multiple routes that it could have. Who is responsible for this routing is the network layer. Okay, there's where we have the routing. All right, remember how many we said that already, that in the device, in the end node. So when we say host or end node, I mean mostly right now, I mean in old books they call it host, now they call it end node, the end node. All right, the end node, how many layers we have in TCP/IP? 5. Starts from the application to the physical. At the router level, how many layers we have?
3.
3. Okay, we have the physical, we have the data link layer, and we have the network layer. All right, so internet is a combination of links and connecting devices. That's what is internet. Clear? All right, let's move on. So let's take a look. So what will happen when the data goes from here to the destination? It will be doing switching. All right, it's like when you go to New York. What do you do when you go to New York in your car? You keep switching from road to road, from road to highway, to another highway, to a local road, then to Greenwich Village. You pick a nice restaurant there, you have a dinner, and then when you go back, okay, again, I switch from a road to another road to another road to FDR, from the FDR to, I'm not sure what is the first highway, then you go to switch to 95, and maybe at 90 at the connector here, you switch from 95 to Route 8, and then to local street until you go to your house. All right, so you're switching. The same thing in here happening in here. So how is switching is happening? How is switching is happening? That's a very important thing. All right, so from the previous discussion, it is clear that the passage of the message from the source to the destination involves many decisions. You have to decide, you're gonna go take this route or this route. How? Okay, when a message reaches a connecting device, a decision needs to be made to select one of the output ports through the switch packet needs to send out. In other words, the connecting device acts as a switch that connects one port to another port. Connects one port to another port. All right, so so far there's nothing complicated, I guess, right? End of the lecture, like always in the end of the lecture, to go slow as much as I could. Uh, Let me try this. Okay, let me try this. All right. So we got this right. Okay, so now let's take a look at how data is switched. So there's 3 techniques actually. There's something called circuit switching, which is like the phone. There's a packet switching, and there's a third one. Anybody knows what's the third one? If the person knows what's the third one, I'll take him or her for lunch. Nobody wants my lunch, right?
Huh?
What? Who's talking right now? Just
Me, Justin.
Justin, where's your photo? Anyways, the answer.
No. No answer, but also no photo.
No answer.
Yes. Which
Okay.
gasket?
What is it?
Gasket switch.
Cascade?
Yes.
Are we fixing cars here? No.
Is it messaging or something?
What?
Something related to message.
Message what?
Message switching, I think.
Okay. Did you, okay. So who's that? Adil or who said message switching?
I said so. Also.
Who are you?
Arsh.
I can't see you. Who are you?
Arsh Khadani.
Okay. Did you Google it? I mean, you are very smart, but you never be smarter than your professor. Okay, never try. And I'll tell you why. It's a message switching, and I would be surprised if you find it anywhere. Okay, the message switch because it's never been message switching. Okay, I don't think you'll find it anywhere because it's a theory, never been used. All right, it's never been used. I'll explain what is message switching, but in the old textbooks, I mean, they were talking about it, the message switching, and they say why is it not used?
Why is it not used?
Okay,
Okay.
is there an echo there? Could you? Okay, mute. So it's a theory, all right? So mostly it's the circuit switching like the phone or packet switching like the current networks. But remind me if I forget why message network is a theory never been used, all right? So let's talk first about, and still, I mean, whoever answered that, when Corona is over, I'll take you for lunch. I will keep my promise. And I will blame Google for that. Don't worry. Okay. I don't know who you are, but remind me. Okay, but COVID 19 has to finish first. In the circuit switching, the whole message is sent from the source to the destination without being divided into packets. So you create a circuit. That's exactly what will happen when you call. So when you call phone. So what will happen when you pick a phone and you call somebody, you're dialing the number. So what will happen? They will create a circuit for you from you all the way to the destination. They establish it, and then you start communicating. All right. If you know what it is, I mean, this is now is done automatically. All right. But if you have ever watched like black and white movies, okay, when somebody call, right, there's an operator. What does the operator do? Switch you, right? They put a wire between your line and the destination line, and you'll be able to talk if you remember that. And that's now what is the auto mechanic switches does. It create a circuit from source to the destination. So a good example for the circuit switched network is early telephone system, like I explained. So the path will be established between the caller and the callee when the telephone number is called. All right, all the way there is a wire between you, and all the data will go through that circuit. It will not switch. So if I go back, maybe there is a picture in here. So okay, let me go back in here. Okay, in here. So when you call, let's say this is a phone. What does it do? It will establish a link, okay, a circuit between you and the destination, and all the data will go through this circuit. That's why we call it circuit switching. We call it circuit switching. All right, clear? That's what is circuit switching. If you forget what circuit switching, it's like the phone. Okay, it's like the phone. All right, now in the packet switching, what is packet to start with? Let me pick somebody in here. Arzu, are there? Arzu?
Yes, I'm here.
Okay,
Yes, yes,
yeah.
I'm here, Professor.
I forgot what's packet. Could you tell me what's packet?
What a packet is?
Yeah,
That's the message divided into smaller packets, isn't it?
wonderful, wonderful, good. So that's what it is. A packet is like you have a message divided into packets, and we send them packet after a packet. All right, and they have sequence numbers that we could rebuild the message at the destination. Thank you. You mute yourself. So the packet switching is the message is first divided into manageable packets at the source before being transmitted. The packets are assembled at the destination. So each packet will travel by itself. Not to forget, let's say I'm inviting all of you for lunch in Greenwich Village in Manhattan. All right. So if we are using circuit switching, what we will do, we'll have a bus and all of us will go with one bus to that location. If we are using packet switching, so everybody will use his own car and will meet at that restaurant in Greenwich Village, right? So that's exactly what will happen. Okay, the network layer is designed as a packet switch, not as a circuit switch. Phone lines are designed as a circuit switch, but networks are designed like a packet switch. That means the packet at the source is divided into, or the message at the source will be divided into packets. We call them datagrams. We call them datagrams, at that level. Individual datagrams are then transferred from the source to the destination. Okay, and then the received datagrams will be assembled at the destination. Okay, so what we are doing in here, the packet will be switching from one network to another network, or other word in our example, from one highway to another highway, until it gets to the destination. Until it gets to the destination. All right, and the packet is switching, okay, until it gets to the destination, and it's like connectionless. It's like connectionless. So I already explained to you what is connectionless servers and connection-oriented service. All right. So in here, for example, a connectionless packet switch network. What will happen? Okay, it goes from the network to in here. So we divide it into packets: 1, 2, 3, 4, and then 1 goes, 2 goes, 3 and 4 takes a different route. So we did not establish a connection. There is no connection. There is no one circuit. Everyone used its own route, and 2 continues, 3 continues, 1, 3 continues, 4 continues, and all of them will go to the destination, but without establishing one connection. It's connectionless. That's what is connectionless. This is the source, okay, and this is the destination, and there's different routes. If every packet, and all of these built one message, all right, and then it goes to the destination. So the forwarding process in a connectionless network is like you have destination address and you have the output interface. All right. So this is the router. The router, as you see in here, let's go back. This router 4 connects 4 networks together. All right. So the router will have a table. Okay, it will have a table. So if the destination address is A, then use output 1. If the destination is B, whatever is B, then use the output interface 2, so on and so forth. So this is called a routing table. Routing table. So how you know? From the destination address. So the destination address in here, this is the source address, this is the destination address. All right, let's say it has B. It's gonna go in here. That means it has to go through output 2. All right, and they send the packet out in the interface 2, and it will be transmitted, okay, to the destination. So what make a router? A router is the routing table. It's like the map. It's like the map for the transmission. All right, so in a connectionless packet switch network, the forwarding decision is based on the destination address of the packet. Okay, on the destination address. So how the router knew it has to send it in port 2? Because the destination is here. The destination address will decide how to be sent out. All right, that's how it works. So delay in connectionless network. So could we have a delay? Yes. Okay, what will happen? The source in here send it to this router. All right, this is, and you see it's like going down, because this is the time when you transmit the data. It's gonna take time until it arrives the router, the first router in here. It takes some time, right? Then it wait for a time in here. All right, process time. What's the function of the router? Let me ask somebody. I explained that last time, so let me pick somebody different. And here, Saya Kotala, Saya Shoji.
Yeah, I'm here.
Who is this?
Shoji?
Shoji. Okay. What we call the router? Why there is a waiting time?
Why is there waiting time for the router?
Yeah.
Is there like delay?
Yeah, it's delay. Yes, it's delay. It's here delay. You did not tell me anything new. But why there's delay?
Maybe like from like the time it takes to get from the source to that router.
Okay, what's the function of the router? What is the other name for a router?
Um,
Store and forward, right? So
mhm,
the data will be received in the router in this link. It will store it to the
mhm,
memory, and then it's forwarded to from the other. Remember, this router is like two computers. It's like to have two Ethernet cards, right? So it will
mhm,
receive it, and the data gonna go up and down. Remember, there's three layers in here. So the data gonna go from the physical layer, data link layer to the network. It's gonna go like this, and then it go down
mhm,
like that, right? So the delay
mhm,
is for the processing, store and forward processing, right? And it will modify the packet a little bit, right? It will change the Ethernet source and Ethernet address and all of that. So there is why I'm asking. I need you to think about everything. I mean, there is an image between you, so there's a waiting time. So why there is a waiting time? You should ask yourself before I ask you. Okay, there's something have is done there. That's why we have the waiting time, right? Anyway, thank you. So the data now we're gonna go from the source to the router. It will wait a bit. Then it will be sent to the next router. There is a delay, and there is a third delay in here, and this is the total delay. So the transmission, okay, it took definitely. I mean, if there's in the circuit switching, we don't have this delay. Why? Because in the circuit switch, we establish a circuit and gonna go right away like this. So in the circuit switches, there's no these delays. All right, it's one circuit. It will take some time to establish it, but after you establish it, it will go all the way to the destination in the packet switch that you have to have. So now, for the my friend who said message switching, are you still there? Are you still there? Message switching person? Nope. All right, we'll take the dinner from you or the lunch from you. So, okay, the question is in here, what is message switching? Message switching, we don't divide the data, the message into packets, we send it all. So imagine that you send like a whole message and how much processing time and how much, look at the router in here, okay. This router connects multiple connections. So if you are sending a message, this router will be busy forever handling one message and the other connections will be delayed so much. So sending a message does not work. The message has to be divided into packets. That will make it fair for multiple connections at the same time. All right. So message is not a working solution. We don't use it at all. So a connection-oriented packet switch network in here. All right, this is a connection-oriented. I just explained it. So in a connection-oriented, what you do, you establish the connection first, and all the data gonna go through that circuit, and we call it virtual circuit because it's not like a real circuit. It's not a real wire that is established. It's a virtual circuit. So you build the virtual circuit and all the packets 1 and 2 and 3 and 4 will go through that to the destination. So connection oriented packet switching, it will go through that route in the same order, okay, and so on and so forth. All right. What's the problem with this solution? Is there a problem? Why we don't use virtual circuit all the time? Ryan,
It takes time.
go ahead.
Too much cost?
Too much cost?
It takes time.
It takes too much time.
Yeah, I mean, like you're reserving the resources, okay, only for one connection forever. How about the other resources? So utilization for the whole network would be much less, right? Much less. I mean, I'm not sure if you live this time. Sometimes, like in the old phone, I don't think you have experienced this, but we did. You know, when you try to call your family anywhere in the world during the holidays, like Christmas or whatever, so you dial the number. We used to dial the number, right? It's not the number. So you'll get a message. We used to get a message. All the circuits are busy now. Try your call later. So what will happen? What happened? That all the circuits are reserved. So it became blocking. Okay, so this could cause a blocking. It could block some communication. If all the circuits are used, there's nobody else will be able to communicate. However, in the model of the connectionless, okay, nobody will get blocked. People will get delayed. Yeah, I mean, it could be delayed when there's a congestion and there's a lot of transmission, but no one will be blocked. So definitely for the network level, I mean, like internet using connectionless. That's what is it's used for now. Oh, okay. So in a connection-oriented packet switching network, the forwarding decision is based on the label in the packet. Okay, on the label in the packet, and that's what we said. So there is a label, a virtual circuit label add it to the packet, and then it will go through one route. It's not the destination address anymore. So that's exactly how it is. As you see in here, this is your datagram. There's a data, there's destination address, there's source address, and a label will be added in here, incoming label. So okay, so this label is a port 1. You're gonna go to port 1, label 1, okay, and the queuing is gonna go to port 2 and label 2, and then it will be transmitted through the label. So this is outgoing label, incoming label, and will be transmitted to the destination. So sending request packet in a virtual circuit network. Okay, as you see in here, A to B request packet. All right. So A to B, then in here you have A to B, you have the incoming, the outgoing. So port 1 and the label is 14. And the outgoing is port 3 as you see it in here. Alright, so it will A to B, it goes to next, and again in here. Now you go in here again, so the port is 1, going to port 1. The label is 66, all right, and the outgoing port 3, so that's port 3. Now I'm gonna go through port 3, then in here I'm gonna go in here. Now incoming port is 1, and the outgoing port is 4. It goes through 4 in here, and the label is 22, all right, until it gets to the destination. Okay, until it gets to the destination. All right, so in the circuit switching we use label, in the packet switching we use destination address. So setup acknowledgement in the virtual circuit. So right in here, as you see in the previous transmission, this is the acknowledgement packet. So you have to acknowledge the transmission back. So in here you're gonna go now it's gonna go from the label is 77. All right, you're gonna go in here, you see the acknowledgement back, then now it's 22, the label will go there. All right, and it continue, and the label go 66 until the acknowledgement go back to the source. All right, so data and acknowledgement. So flow of one packet in an established virtual circuit. Let's take a look in here. Okay, so that's one packet. That's the whole map drawn for a whole packet. So you have data AB, there's a label 14, it's in here label, and I'm gonna go in here, there's a label because in here 66, it says 66, so it's 66, 22, and 77. And delay in the connection-oriented network. Let's take a look at the connection-oriented network, how the delay will be. You see, it's like once you establish the network, it's all the way less delay. Remember in the packet switching what we did? We did like this, then like this, right? Then like this, if you remember, and there is a wait time in here. Just so you're gonna take some time at the beginning to establish the connection all the way. And the acknowledgement goes back like that. So this is for setup time. So in here, there's some delay for setup time. Yes, you have to set up time. And after that, the data will go all the way with no delays in here, with no delays. All right. And then after that is disconnect. The disconnection. Both parties could disconnect the communication. All right. So this is the setup. This is the tear down time. But you know when you, and this is happens one time. This happens one time. This happens one time. Although it takes some time, it happens one time. But you could send thousands of packets with no delays between them when you have the connection, and that's the total delay. All right. So networking layer services. In this section, we'll briefly discuss services provided by the network layer. Okay, this service is provided to what? To the upper layer, which is transport layer. Remember, there is layer to the upper layer, right? We agreed on that, right? To the network layer. I mean, let's take a look how it works. I hope we have time. Maybe we have time. We will talk about the logical addressing services provided at the source computer, services provided at each router, and services provided at destination. Remember, there is a source, then I go multiple routers, and then I'm gonna go to the destination. Right? That's the logical path. All right. So let's take a look in here. I hope it's clear. Okay. All right, so in here, so look at in here. Let's just explain. Okay, this is Alice. All right, Alice. This is a wonderful publishing company. They have multiple computers. Alice is sitting in here. It's connected to a switch. All right, they are connecting it through a cable, like myself right now, connected through a cable. This cable will connect you to a regional ISP, Internet Service Provider. Let's say Charter, for example. All right, and Charter will connect you. There is many routers connecting them. Then this will connect you to the SONET. Remember trunking? It will collect all data from multiple network. Then it will trunk it. All right, SONET network. So this is the national ISP hub. Okay, so you'll have an ATM as a core in here, multiple routers. Okay, then again it's gonna go to ServNet, another company in here. Okay, and this is a regional ISP. So regional ISP in here and another regional ISP in here. So let's say this is in Trumbull, Connecticut, where I live, and this is in Bombay, India. Okay, anywhere, Shanghai, China, Cairo, Egypt, anywhere. Okay, all right. So all right, so look how data goes. So let's take a look at the colors first. So blue is the application layer, a transport layer, network layer, data link layer, and the physical layer. And this is in here point to point one, this connection point to point one. This is DSL modem, this is a cable modem. All right, so I am here, I have a cable modem. When I communicate, I will be connect point to point to the regional ISP. Okay, and the regional ISP, all right, it's only routers, right? There's no computers. So how many layers we have? Three. We have physical, data link, and we have network, right? Then this will be connected to the SONET, which is national ISP. right? National ISP, as you see it in here, okay? The national ISP. All right, so this again is like many switching. So router 3, eventually gonna get to the router 3. Again, we have 3 layers. So at my destination, I have 5 layers in here. And here I'll have 3 only layers. And here we have 3 layers. All right, then it will connect to a regional ISP in here. Again, router 5 and router 6, whatever. All right, and let's say I'm communicating with Muhammad Al Jamal. He's in Cairo right now. Okay, let's say. All right, and this guy does not have a cable like me. He has only a DSL connection over the phone. So this is over the cable company. This is over the phone company. All right, and then the data gonna go all the way to have, forget about pop. This is Muhammad Al Jamal. Okay, in Cairo. All right, and the data will go there. So I mean, that's how it is. Of course, this is me, this is him, this is the regional ISP. Maybe there is multiple hops in between. Doesn't matter. So look how the data goes. It goes from the application to the physical. It reaches in here. It goes from the physical up to the network, from the network to the physical, physical to the network, network to the physical, physical to network, network to physical, physical to network, network to physical, physical to network, network to physical, physical to the application layer. Very nice, very smooth. All right, okay, and let's take a look at the IP address. So the IP address will never change from here to here. So the IP address in all the packets as a source in here, it will be the same all the way until it goes to the destination. What will change? The MAC address. Remember we explained that? So the MAC address, when it goes from here to here, it will the source and the destination. Then the source and destination will change. Source and destination will change. Source destination will change. How about the port? It will be the same access port all the way. All right. So the MAC address will change. The IP address will not change until the end. So services are provided at the source computer, as you see in here. So you have in here the data, the link, the destination address, the PI, which is the protocol ID, the ST, which is the source service type, is in here. So it will be the length of the data. DA will be the destination logical address, which is the IP address. All right. PI, which is the protocol ID. ST is the service type. This is the upper layer. I'm gonna go to the network layer. Look at the network layer, how big. Okay, so then you're gonna do packetize. You're gonna create a packet. This will be a datagram. Then find next hop logical address. Where do you find the next hop logical address? From the routing table. Okay, so you tell the destination address until you know the next hop logical address, NA next hop logical address. Then you're gonna go down. You'll have a datagram plus the next hop logical address. Then what's next job you have to do? You have to find next hop MAC address, and for that we use a protocol called ARP. We'll talk about it later. The ARP, and the ARP you'll send it. Okay. Oh, you tell it. Okay, this is the next hop logical address. Then it will look for it. The ARP will look for it and will send you the MAC address, the hardware address. Good. Then we have a datagram. So in here, datagram and plus MAC. Now I have a MAC, right? What we do with the MAC, all right? So the link. So remember the MTU. What is MTU? Maximum transmitted unit, right? Okay, MTU is the maximum transfer unit. All right. So you're gonna tell the link, all right, and we'll check the link. What is the MTU? Okay, we'll check what is the MTU table. So the MTU table is this. Why we need to do that? Because if the MTU is smaller and the packet is bigger, what we have to do? Fragment it. We have to fragment it, right? Then it goes to the data link layer. So what will happen in the data link layer? Very nice, very sequential, very, it's like a music. I mean, myself, when I look at the logic, I feel like I'm listening to Beethoven. It's like a very nice logical thing. Things step by step, it goes smoothly, right? So upper layer, network layer goes to the data link layer. So in here, what you're gonna do? Okay, depends on the MTU. If it's like smaller than the fragment in here, what are you gonna do? You're gonna divide it into fragments. So fragment 1, fragment 2, fragment 3, for example. So you have the datagram header, okay, and you'll have the MAC, all right, the next hop MAC, and so on and so forth. So now you have, instead of one packet, one datagram, you have three, all right. I have three. So again, in here, when you take a look in here, transport or okay, then network, the process, then the data link. Okay, can I go down? All right. So in here, processing at each router. So this is at the source. This is at the source. Let's take a look at the router. What will happen at the router? All right. So the router will receive the packet. So find the next hop logical. So again, what does the router do? Receive the packet and send it to the next hop. So it needs to find where to send it. And that's why the router has a table, routing table. So it will consult to the routing table. It will tell the routing table, I have the destination logical address DA is this. Tell me what is the next hop logical address. Then it will send the next hop logical address to it. Now it goes down datagram and the next hop logical address. Do we communicate with the logical address? No. What we have to include? The physical address. But I don't know the physical address of the next hop. Don't worry. We have ARP. So it will send to the ARP the network logical address to the ARP, and the ARP will send the MAC address. Great. Now I have the datagram and I have the MAC address of the next hop. Wonderful. Then it goes down, you have the fragment now. Now I need to know about the MTU. Okay. Is it like bigger than what I allowed, smaller? All right. So if it's okay, so then it does the fragmentation, data link layer outgoing interface. All right. Um, all right. um, and data link layer of incoming interface. Anyways, this is like going out for incoming interface. When it's go up, it will check if the discard datagram false. If it's a true, you're gonna go back in here. Anyways, so that's a process. Data link. You're gonna go through the network layer. You're gonna go through the data link again. The next data link. Okay, incoming, outgoing. That's the path gonna go. Now let's take a look at the process at the destination computer. Now the destination receiving from bottom up. So we have to start in here. So to receive the data with the header, that's the data link layer. It's gonna go up. All right. So it's gonna check, is it a valid datagram? Remember the CRC? Okay, it will be able to check there. False, discard the datagram. It's no use, it's corrupted. All right. If it's a valid one, then you go up and you depacketize it. All right, you depacketize it. All right. Um, so now you need to, if you have multiple fragments, you collect them in here because you have to order them first. Remember, the packets could arrive out of order, and to build the message, they have to be in order. All right. So it's gonna go here. All the frames arrived. True, reassemble. So you see the packets in here came in here together. We're gonna go in here and it will assemble. So packet 1, then packet 2, then packet 3, then packet, okay? It will build the message again. All the frames arrived, no, false. Then you go in here, you check again, reassembly timer expired. So you keep waiting. So let's say that you received packet 1 and packet 2, 3 did not receive 4. What are you gonna do now? So you are not going to wait forever, right? What you'll do, you put a timer. So hopefully the missing packet will come. All right. So in here, all fragments arrived. No. So what I do, I'll put a timer. Okay. And if timer expires, if the timer expires, discard all the fragments. Sorry. Either we receive them all or discard them all because we cannot build the message, right? We can't build the message with a missing. If it's okay, until we find them and reassemble them and deploy them. Very nice system, right? So in here again, the destination computer, data link, network, transport layer. And if the message is too big, you fragment it, you send it the way you want. Each packet will take its route until it arrives to the destination, and then reassemble them, and everything will be perfect. I think we'll stop right here, and we'll continue